molar conductivity is nothing but molar conductivity of a solution when the concentration approaches to 0, or a molar conductivity at infinite dilutions. The most one is oiling, painting. In addition to this, by using electrochemistry, the rusting can be prevented by the production of barriers like painting, metal coating, or with electroplating, etc. So if you increase the dilution, what will happen? The conductivity will be decreases with increasing in dilution. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to do with a revision for the Unit 3, that is Electrochemistry. Okay, so before going to start with the Electrochemistry chapter, let us see what we are going to understand more about the Electrochemistry unit. Okay, electrochemistry, we all know that it is a branch of chemistry which deals with the study of production of electricity from energies released during the spontaneous chemical reaction, and this electrical energy will be bring about the non-spontaneous chemical transformation. Okay, now what are the importance of this electrochemistry in our daily life? So we can use this electrochemistry techniques for the production of metals like sodium, metal and calcium and aluminium, in electroplating and in the purifications of the metals and the batteries and the cells, which is used in the various instruments. Coming into the most important part of this unit, in this unit there are two parts will be there. One is more about the conductivity, and another thing is more about the types of cell. Okay, that is very important. Understand from this unit. Okay, let's see the weightage of this unit first of all. So from this unit, we can expect the 10 mark. So you can see that there is a 1 mark question, that is a question number 4, and in a part 2, that is question number 18 and 19, which carries 2 marks, and definitely from the part D, one question which carries a 5 marks. In that, there are equation based upon numericals can be asked for 3 marks. Now we will see which are the important questions which has been repeatedly asked in this unit, that is a 1 mark, 2 mark and a 3 mark question. So the first 1 mark question is, as I said, in this unit there are 2 parts will be there, a distinct part. In that you are going to study about conductivity, then later on with the types of cell. Okay, so in that you have to understand, define limiting molar conductivity. Limiting molar conductivity is nothing but molar conductivity of a solution when the concentration approaches to 0, or a molar conductivity at infinite dilutions. So molar conductivity of infinite dilution, which we represent like this. Next, state Kohlrausch law of independent migration of ion. We know that Kohlrausch law is a law which has been given by Kohlrausch scientist. He has given a different methodology to indicate how to find out the limiting molar conductivity of a solution or for the given compound by counting with number of individual ions which are responsible for that formation. Okay, limiting molar conductivity of an electrolyte is represented as sum of the individual contribution of anions and the cations of the electrolytes. As I said, for example, if I write limiting molar conductivity of the sodium chloride, I can write limiting molar conductivity of the sodium chloride, which is equal to limiting molar conductivity of a sodium ion plus limiting molar conductivity of chloride anion. Okay, this was a scientist who has given this idea. Then state Faraday's first law of electrolysis. As I said, so in the types of cell, you are going to study about the galvanic cell, Daniell cell, SHE, standard electrode potential, then standard hydrogen electrode, then with the laws which has been given by the scientist. Okay, all these things you are going to understand with the second part of this unit. In this, Faraday's first law and Faraday's second law and Kohlrausch law are very, very important. So it can be asked for 1 mark also, or for 2 marks also sometime. Okay, the amount of electrical reactions which has occurred at any electrode during electrolysis by a current is proportional to the quantity of electricity which is passed through the electrolyte, either through the aqueous solution or to the molten state. So what does the first law states that? In the first law, we can expect The amount of chemical reactions which is occurs at any of the electrode, how much you are producing the electricity to the molten state of an electrolyte, which are directly related to one another. Next, state Faraday's second law of electrolysis. The second law states that the amount at a different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weight. Suppose you are finding out the, or you are passing the electricity to the two different electrolytic solutions which are having a different weights of the substances. Okay, when you pass the electrolyte, you know how much the substances get liberated, they are directly related to the chemical equivalent weights. Next, what are fuel cells? The galvanic cells that are designed to convert the energy of combustion of the fuels like hydrogen, methane, etc. directly into electrical energy. They are known as what? Fuel cells. Then give a method to prevent the rusting. We know that rusting is the most important one which we face till now also. For that, you know, different process and different kinds of prevention that we use. The most one is oiling, painting. In addition to this, by using electrochemistry, the rusting can be prevented by the protection of barriers like painting, metal coating, or with electroplating, etc. Next, name the gas which is liberated anode during the electrolysis of sodium chloride. So, during the electrolysis of sodium chloride, you know, at anode, the chlorine gas will be liberated out. Next, the chemical name for the rust is, this question can be repeatedly asked in many exams. So, the chemical name for the rust is Fe2O3, that is ferric oxide with X amount of oxygen. Okay. Next, for the 2 mark question, mention any two factors in which conductivity of an electrolytic solution is depends. So, we know that the conductivity of any electrolytic solution depends upon the nature of the electrolyte that we take and how much concentrated electrolytic solution we have taken for the entire electrolysis. These two factors which mainly depended. Next, what is the effect of dilution on conductivity? Give an example. So, if you increase the dilution, what will happen? The conductivity will be decreases with increasing in dilution. As you add more and more dilute or if you take in sodium chloride, if you dilute more and more, you know, their conductivity will be decreases because upon dilution, you know, number of ions per unit volume will be decreases. If the number of ions decreases per unit volume, obviously the ions which are responsible for conducting the electrolysis, you know, or electrolytes, you know, that will begin decreases. That is why, you know, conductivity will be decreases. Next, what is the effect of dilution on molar conductivity? Give an example. So, it is a reverse of that. Okay, in molar conductivity, you know, the conductivity will be increases with increasing dilution. So, in a molar conductivity, we say that as we do with the dilution, the conductivity is also increases because the total volume of the solution containing 1 mole of an electrolyte increases. As the number of electrolyte increases, the conductivity is also get increases in case of molar conductivity. Next, name the gas which is liberated anode and cathode when aqueous solution of sodium chloride is electrolyzed. So, at anode we know the chlorine gas will be liberated, at cathode, you know, hydrogen gas will be liberated out. Next, draw the neat label diagram of SHE and write the symbolic representation of the cell and write the half cell reaction. So, this is a construction of SHE, that is a standard hydrogen electrode. So, in the standard hydrogen electrode, remember this is a cell that we constructed to measure the electrode potential of an unknown cell. Okay, to measure that we have taken SHE as a standard one. Okay, whose electrode potential will be always 0. Okay. So, the standard electrode potential can be constructed by taking the large container. In that we have taken 1 molar hydrochloric acid and we have immersed a platinum electrode which has been coated with a platinum black, and we have a opening at this entire electrode which is for pumping the hydrogen gas, and this is a platinum wire, you can see that, and we have a high resistance voltmeter to measure the conductivity. Okay, in SHE, you know, we always represent a cell like this, that is a platinum in the hydrogen gas. So, in the H2, we know that hydrogen gas will be generated. So, when we immerse this platinum wire, you know, when we pump the hydrogen gas to this entire container like this, the hydrogen gas will be bubbled out. So, this hydrogen gas in 1 molar with a pressure of 1 bar plus H plus ions in the aqueous medium of 1 molar. And remember, in SHE, their electrode potential will be 0 always. Next, calculate the limiting molar conductivity of the calcium chloride they have given. Given that the limiting molar conductivity of the calcium ion and the chloride ions are they have given, we have to find out what limiting molar conductivity of what? Calcium chloride. So we know that limiting molar conductivity of a calcium chloride is obtained by limiting molar conductivity of a cation, okay, plus 2 into limiting molar conductivity of chloride ion. So what is the calcium limiting molar conductivity? They have given 119.0 plus 2 into 76.3. If you do the simple calculation, you will get 2 marks. So it is 119.0 plus 152.6. If you add 152.6 with a 119, you will get 271.6. This is a limiting molar conductivity of calcium chloride. Why I have taken 2 here? Because you must know that this calcium chloride will be dissociated and to give calcium plus 2 ions and 2 chloride ions. So that is why I have written into 2. Okay. If it is sodium chloride, you can write sodium plus chloride. Okay. Need not to multiply with any integers. Next. 3 marks will solve with the sum of the numerical based upon the Nernst equation. Okay. Calculate the value of standard free energy change at 298 Kelvin for a cell reaction. They have given 2 Mg plus 2 Al3 plus, which gives us to the 2 Mg plus 2, 3 Mg plus 2 plus 2 Al. So given that E0 for the Mg and E0 for the Al they have given, and Faraday's constant we have to they have given. So we have to calculate what? Delta G0, that is the standard free energy change we have to calculate. If they have given, it is 96,487. 96,487. So now they have we have to calculate what delta G0, and if they have given, we have to calculate the E0 of the cell. E0 of the cell is obtained by E0 of the cathode minus E0 of the anode. E0 of the anode. Always remember, when I say it is anode and cathode, you remember with the AOL, R and CRR. Okay. So A stands for anode and C stands for cathode. In anode always oxidation will take place, and in the cathode reduction will take place. You can see that. So here at a cathode, in the sense aluminum will be there, which is acting like a reduction electrode. So I'll write E of Al minus E0 of the Mg. So what is the Al value they have given? Minus 1.66 minus EMG is 2.36. Okay, minus 1.6 is minus into minus, it is plus 2.36. How much you will get? 0.70 volts. 0.70 volts. After understanding with the after finding out the E0 of the cells, we need to calculate what? Standard free energy change. Standard free energy of the change, which is obtained by with this equation, minus N F E0. Okay, so what is N? N stands for number of the electron which has been lost. You can see that 2 electrons will be lost with the magnesiums. 2 3s is 6. So I'll write minus 6 into what is F they have given? 96487 into what is E0 value? 0.76. If you do with the multiplication, you will get a final value as minus 405.24 kilojoules. So delta G0 value is minus 405.24 kilojoules. This is how the standard free energy change can be calculated with the above data. Next, calculate the EMF of the cell in which of the following reaction which is taking place at 298 Kelvin. So they have given nickel and aluminium, they are going to undergo both oxidation and reduction, and E0 of the cell which is also given. So finally you have to calculate what? EMF of the cell. So we know that EMF of the cell is obtained by a specific equation, that is E cell is equal to E0 of the cell minus 0.0591 divided by n into log of anode and cathode. So here I'll write the nickel directly divided by concentration of silver. Okay. Now what is the E naught value? They have given 1.05 minus 0.0591 divided by how many electrons will be lost by the nickel? 2 electron. So into log of what is the concentration of the nickel in a +2? It is 0.160 divided by what is the concentration of the silver? So it is 0.002. So first divide 0.0591 divided by 2, you will get 0.029 into log of here you can see that I have written the concentration of the silver. You can see that the silver can loses 1 electron, thereby there are 2 silver atoms will be there, into whole square I have to do. So log of 0.10 divided by 0.02 into whole square, it is 40,000. Okay, log of 40,000, it is nothing but it is nothing but 4.6021. Okay, this is a log value for the 40,000. Now multiply 0.029 into 4.6029 and then subtract with a 1.05. Finally, you will get 0.914 volts. This is a EMF of the cell. Okay, this is how if E naught is given, we can place the E naught and we can calculate the EMF of the cell. Next, calculate the equilibrium constant for the reaction. So CO, that is copper plus silver, which is given as Cu2 plus Ag, and E naught of the cell, which is also given. So you have to calculate what? Equilibrium constant. So I'll write the equation first, that is E naught of the cell which is equal to, since they have not given E naught, they have directly given. So I'll write 0.0591 divided by n into log of Kc directly. Okay. So what is the EMF of the cell? It is 0.46. 0.0591 divided by how many electrons will be lost? 2 electrons into log C. Correct? Now, as I know, we have to calculate the equilibrium constant. I'll take the log Kc outside. So, I'll multiply 0.46 into 2 divided by 0.0591. So, 0.46 into 2 divided by 0.0591, you will get 15.5392. So, now we want, this is log Kc, correct? So, we want Kc only. If log goes outside, it will become anti-log of 15.5392. Okay. So, if you find out the anti-log for the 155392, you will get, so the log value, if you divide 0.46 into 2 divided by 0.0591, you will get 15.593 actually. It is 15.593. So, you have to find out 15.593 anti-log. You will get 3.92 into 10 to the power of 3. This is a equilibrium constant value for the above reaction. This is how, if an equilibrium constant is asked, sometime if you ask you to calculate the EMF of the cell, or if they ask you to calculate the free energy change, any of this numerical can be expected for your board exam. Hope you all understood. I have taken out one numerical based upon the different equation we have learnt in the electrochemistry. Hope you all understood with the session. I'll come back with the next chapter. Till that, take care and be safe. Thank you.